Alright folks, we're going to give you a brief rundown on the explanation of the demos that we saw in the previous video. So you can update these explanations to your Google Doc if you would like, and then make sure you submit that to Schoology. So, the explanation, what's happening in there? Well, first thing is you have a diaphragm. I'll put a picture on the screen here of what's going on. But your diaphragm is a muscle, and as it expands and contracts, it makes your lungs bigger or smaller. And so when it makes them bigger, increases the volume, it forces that air from outside into your lungs. It creates low pressure inside of your lungs. And so the high atmospheric pressure pushes the air down into the area of low pressure. So if we had to draw a particle diagram, we would draw high pressure out here, low pressure inside your lungs, high pressure forces that air into low pressure. Cool. Let's do demo number 2. See the milk carton? Just increases in volume. Yeah, isn't that great? So, explanation number 2. I took milk from a cold refrigerator and put it on a warmer surface where it heated up. So we're relating 2 variables. We've got temperature and we've got volume. So since I screwed the cap on, it's a closed system, no air is getting in or out. And as the temperature increased, the volume also increased, which made that milk jug just ever so slightly increase. And if I heat it up even more, it's going to increase even more. That's where we get that boom. Just the little milk carton expanding for us. That's great. So, the explanation for the yeast, the reason we don't screw the cap on super tight is because what's happening is a chemical reaction that's creating a gas. So this would be Avogadro's law. If we create more moles of a gas, the volume also increases. So you can see the air bubbles in that yeast expand, and if we were to leave the cap on, we could create an explosion with a glass bottle. That wouldn't be so good. That's what makes great big hole sourdough. Ask Mr. Lackey if you have more questions about that. All right, so we're getting toward the end of the day. Wow. So, explanation. So this one's interesting. What happened with the can is that we heated up the water, which created a hot gas inside of it. As gas heats up, it expands, and it was open on the top. So we had an open system. We don't want to worry about that. We want to worry about when it's closed. So we very quickly flipped it over into the ice cold water, creating a closed system. So what happened in that closed system? First of all, it cooled down a lot because it went from boiling temperature to ice cold. So when it cooled down a lot, temperature went down. What else did we see? We saw the can get crushed. So we can think of this in 2 different ways. Number 1, the volume decreased. When we decreased the temperature, we decreased the volume. But also, there's another thing involved, and this is the atmospheric pressure, which we talked about earlier. The atmosphere is pushing on your body with 14.7 pounds of pressure per square inch. So 1 little square inch, there's 14.7 pounds pushing down. So imagine that on all the sides of the can, crushes in on it. So it reduces that volume. So this one combines all 3 variables, pressure, volume, and temperature, before and after, which makes it the combined gas law. That's merely 4 examples of chemistry in your everyday life. And if you know the right tools and you know what to look for, you can find it everywhere. So I challenge you to come up with a few more examples. Extra credit, bonus opportunity, write some at the bottom, and see what you can come up with.